Hello everyone, welcome to my video log about my first ever tube amp build. This is going to be a multi-part series that documents my process as I build this amp, and I hope to share what I learned along the way with you guys. So if you're planning to build your own tube amp, you might find this helpful. Okay, so my goal for this build is to learn the basics of tube amplifier construction and circuitry. I actually hope to be able to work on tube amps professionally at some point, but I still have a lot to learn, as you can tell. With this project, I'm not really trying to build a amazing amplifier, just you know just something simple to get some hands-on experience with. I'm doing this on a really tight budget, so I'll be using locally available and recycled parts whenever possible. In the end, I hope to end up with a decent guitar practice amplifier that could occasionally also be used as a general purpose audio amplifier for my other projects like radio receivers. But honestly, the end result isn't as important to me as the process. Okay, so I spent some time thinking about what circuit I should build this amp according to, and I originally considered of old Fender circuits such as a Fender Champ or a Bassman, but in the end I decided to go with this AX84 schematic. So you might already be familiar with the AX84 project. What it is basically a collaborative open source kind of tube amplifier project that some guys came up with in the late 90s. Unfortunately, the project doesn't seem to be active anymore, but there's an archive of the project available on the URL. I will link to it in the description, and I've written the URL at the top of the slide, as you can see. So the reason I took this particular schematic is because it is very well documented. I could find a chassis layout for it, and it uses valves that are easily available relatively inexpensively for me. I am located in India, so I went with something that uses valves that are that used to be very common in the Indian made valve radios of the 60s, like the EL84. This uses an EL84 output stage and a 12AX7 input, two 12AX7, one 12AX7, but a 12AX7 is the dual triode, so two 12AX7 preamp stages. So let's take a quick look at the schematic. So the signal enters here at the input jack. We have the first 12AX7 preamp stage that is capacitively coupled to the volume control, and then we have the next 12AX7, which is also known as ECC83. That's what we called it here, preamp stage. And then we have the Fender Marshall Vox. Is it the Fender Marshall Vox? I think that's what they call it. FMV tone stack, and the tone stack feeds the output stage, which is using a EL84 tube. And of course, we have an output transformer, and the original schematic uses an output transformer with taps for different speaker impedances. I will not be doing that. I'll work with just an 8 ohm speaker because the restrictions of the transformer that I decided to use. And this is just the power supply section. I'll talk a little bit more about the power supply section a little bit later, because I'll have to alter this slightly because to compensate for the parts that I have available to me. Okay, so this is the chassis layout that I'm working with. I found it at the URL which is listed here, and he's this by a guy called Pedro Guy. And yeah, thanks Pedro for putting this together. As you can see, he has provided a chassis layout looking at the top, and also the wiring layout. So you can see how everything is hooked together. And there's actually a few more layouts available for the AX84 if you search online, but I decided to go with this one because it uses tack strips as opposed to a turret board, and I really wanted to use tack strips for my, I don't know, you can call it a terminal strip or a tack strip for my first build as opposed to a PCB or even a turret board. I just feel that that's the way they did it in the old days, so I should do it that way. I mean, yeah, the Fender amps use turret boards, but I believe the earlier ones did use tack strips, and the old radios like the Philips radios that I've used to seeing, they all use tack strips. So I have an affinity for them, let's just say. So yeah, I'm basically following this layout as much as possible, but I did extend the depth by around an inch to make more room. And yeah, so basically, yeah, the dimensions are pretty similar to this, except that 1 inch extension of the depth. Now transformers are arguably the most critical and expensive parts of a tube amp build. To save costs, I'm working with an output transformer and a power transformer removed from a junked Philips radio from the 60s. This radio used an EL84 output stage, just like the AX84, so I'm hoping that the transformer choice shall be suitable. We'll get to the output transformer in more detail in another part of this series, but I will talk about the power transformer later on in this video. But first, let me show you how I put together the chassis. Okay, so I started out with a sheet of 18 gauge sheet metal and I decided to use a chassis fabrication technique shown by Uncle Doug in one of his excellent videos. If you aren't already subscribed to Uncle Doug, you definitely should because he's one of the best YouTubers when it comes to valve amplifiers. So I began with marking out the cuts and folds. I plan to use these giant metal cutting scissors or tin snips or whatever you call them to cut the sheet down to the appropriate size. But it turns out that it wasn't going to be that easy. I mean, the guy I bought these big ass scissors from did say it would be a piece of cake, but it didn't turn out that way. Okay, so here on the left, you can see a clip of me doing some test cuts. And as you can see on the right, the results were not very good. So being too broke to purchase any power tools, I decided to outsource the cutting part of the fabrication, which was kind of disappointing as I wanted to do as much of it myself as possible, but this just wasn't working out. So I took the sheet of 18 gauge metal down to the local neighborhood auto body repair guy, and he used a similar set of scissors to cut the sheet down to size. He really has the technique down. As you can see, he makes it look really easy, but it's not. I actually tried to copy his technique once I got home with another sheet, but it's really not as easy as he makes it look. I was very impressed by the straightness and the finish of his cuts, even though he told me that he couldn't guarantee that they would be 100% perfect. They looked damn near perfect to me. Back home, I used some C-clamps and an angled beam to fasten the sheet to our kitchen table. I then proceeded to hammer the metal into a C shape as Uncle Doug did in his video. As you can see, the kitchen table took quite a beating, and so did the sheet metal. Once a rough fold was made by the hammer, I used a piece of wood to straighten up the lip as seen here. Here is the overall view of the setup. The 18 gauge sheet metal is actually quite thick, so it really took a lot of effort to get it into shape. I definitely recommend you to use a thinner sheet if you are planning to do this. Uncle Doug actually used a thicker sheet in his video, so hats off to him for the results that he was able to achieve. So here's the chassis after the bending was completed. The proportions were actually kinda janky and we had to sort of twist it into shape so that it would sit level on the surface. I actually considered starting over from scratch or getting a pre-made chassis, but I was really itching to get started with wiring this amp up. So in the end I just decided to embrace the imperfections and just go with what we had. So the open sides of the chassis definitely seemed like an electrocution hazard. So I took the chassis back to the audio auto body shop and had them weld some sides onto the thing. Here's a close look at the chassis at this stage. You may be able to make out some of the imperfections. Also, you may have noticed where I tried to drill the tube socket hole. Drilling into the chassis turned into another ordeal in itself. So let's see how that went. So here's me drilling the front panel holes while my dad holds the chassis. As you can see, it took quite some effort. Maybe I need a more powerful drill, but it did work out in the end. Now, drilling the holes for the potentiometers, switches, etc. wasn't too bad despite it taking quite a while to drill through the chassis. But the difficult part was really drilling the two tube socket holes. Now, I don't have any footage of that in progress because I was quite flustered trying to get it to work, too much so to record. But what I tried at first to drill them with was a hole saw attachment. This failed miserably with the saw edge of the whole saw thingy actually getting sanded smooth by the chassis surface. Then I tried a stepped drill bit as on the right, which worked okay but not very easily. Maybe I was using a poor quality bit or maybe my drill wasn't powerful enough. But thankfully there were only two tube socket holes that needed to be done. And yeah, we did manage to drill the holes, but it took a lot of time and at, at points it seemed like the step drill bit is not doing anything, but we persevered and just got it done somehow. After that, it was simply a case of filing and sanding the surfaces to get it all smooth and shiny, and riveting in the terminal strips, of course. I decided not to paint the chassis and just sprayed it with some clear lacquer. I think it looks pretty badass, honestly. Right, guys, here is the chassis completed. Everything's fitted except the tube sockets, which I'm still waiting for. Got the input jack, volume control. This I believe is the bass, middle control, treble. All the pots are mounted. We've got these cool knobs from rovu.in. I'll put the link in description. We have a standby switch, nice clunky on-off switch. It says on, so I have to fix that. And something just fell off, but let's see. This is the LED holder. Here you can see where I've riveted on the terminal strips on the other side using a handy dandy pop rivet gun. Output transformer from the Philips radio. This I believe is the primary windings, and plus there's an additional filter coil, filter choke, and power transformer. Well, the exposed leads on the power transformer and the output transformer are definitely an electrocution hazard. So I'll have to think of a way to insulate that. Probably just use heat shrink. Let's see. But for now, let's take a look at the back. We've got the fuse holder, this little grommet from which to feed the three-prong power cord, banana plugs, which I might use for an external, not external, DC output, 250 volt DC output. So I can power an additional project like a radio receiver, something like that, tube radio receiver. And this, well, I'm not sure how I'm gonna wire that. I might not even do it, but I'll just put this on just in case I decide to. On off switch for the DC output in case I do wire it. Output jack, and this I'm not sure what I'm going to be doing with it yet, but I'm thinking like switchable negative feedback, so a clean mode and a distorted mode, something like that. Probably gonna use it to switch negative feedback on and off because the original circuit does not have negative feedback. So let's see, and let's turn this over. So here's the back, terminal strips all mounted, so it's pretty much ready to start the wiring. I'm going to start with the power supply, which is will be all here, the filter caps, etc. The back of the double pole double throw power switch, on off switch, back of the pots, I don't know if you can see them, back of the input jack, and the other side, all this junk, and holes for the tubes. As you can see, I goofed up on quite a bit of the drilling, so you have an extra hole, but it's part of the aesthetic, let's just say. and I guess use whatever hardware I had in the junk drawer or at the local hardware store. So if you're a nerd about fasteners, you're probably going to say that these are the wrong fasteners to use, but whatever. And so I wasn't very happy with the finish of the chassis at first, but I guess I'm going to go for a rustic wabi sabi fallout steampunk kind of look now and embrace steam perfections, including the grime on the transformers. Classic vintage Philips Calcutta grime. I think it's tar or something on some parts of the transformer. So here's the Philips radio chassis that was cannibalized for the transformers. It was by no means a restorable radio, so you vintage radio aficionados can uh, sleep at night, I guess, knowing that I have not destroyed an immaculate vintage radio. So yeah, so this had an EL84 output stage, which is why I hoping that the output transformer should work well for what I needed to do. Here it is, Philips B4CA 27A, made in India. And yeah, the power transformer had inputs for 110 volts, 180, 205, so which suggests it did export these things, but I have no evidence that they actually did, so I don't know. Maybe they did, maybe they did not. Who knows? I've never heard of anybody seeing a Philips Calcutta radio out of India ever, so who knows? The mystery shall remain unsolved. Okay, so I wasn't able to source any axial lead capacitors locally, electrolytic capacitors, and importing them is out of the question due to budgetary concerns. So what I'm doing is taking these standard radial types, soldering a little extension onto them, heat shrinking them, and bending them as such so that they can now be installed as if they were axial lead types onto the tag strips. Okay, so I'm going to talk about some of the changes that I had to make to the original AX84 power supply. On the top we have the original circuit, and at the bottom we have the Philips radio power supply circuit. The first major difference is that the AX84 uses two silicon diodes for rectification, while the Philips radio uses a dual diode vacuum tube and thus has a much higher secondary voltage. I measured 255 volts to the center tap and 510 volts across the whole thing. The other difference is that the Philips uses a filter choke for additional filtering to the B plus line going to the preamp and RF stages. This choke is actually located in the output transformer, and I have a feeling that this connection is essential to the proper functioning of the output transformer, which may sound strange, but if you think of it like a push-pull transformer, which has the two out-of-phase DC currents in the two halves of the primary winding that cancel out, so you don't need an air gap in the transformer. So maybe there is something like this at play here, as in the DC power supply current may be cancelling out some of the core saturation effects of the single-ended EL84 output stage quiescent plate current. I have heard that these Philips transformers tend to be rather finicky if not used exactly as intended. So I do want to work in the filter choke in my circuit somehow. So these two problems need to be worked out. The higher secondary voltage and the need to use the choke. So this required some tweaks to the AX84 power supply that so that we get the right voltages for the EL84 here and for the 212AX7 preamp stages over here. So we need 250 volts for the EL84 and 233 volts for the preamp stages. So let me show you the changes I had to make to the circuit and how I worked out the component values that I would need to change. Okay, so here is my modified circuit. At the top, I picked the values after going back and forth between the actual circuit and the excellent PSU designer software by Duncan apps. Starting from the left, you can see that I only used one of the secondary windings connection to the center tap, and a full bridge rectifier. Electro boom, I hope you're proud of me. This gave me around 360 volts DC after the rectifier with no load. Now to work out the resistor values, I had to estimate the load resistance of the tube stages using the voltages on the AX84 schematic and the cathode resistance values to infer plate currents. I could then get the equivalent DC resistance of each stage by dividing the V plus voltage by the current, the quiescent plate current of that particular stage. Here you can see I have shown the stage resistances in gray. The output stage works out to be around 4404 ohms over here, and the two 12 AX7 stages in parallel work out to be around 138K. Now, all this is too complex to model in the PSU designer software, but fortunately I could simplify it down to this. That's because all of this all of this, the series combination of R1 and L1 in series with the parallel combination of both the preamp stages. All this appears in parallel to the EL84 stage, but since this resistance is much more than the EL84's equivalent DC resistance, the EL84 stages equivalent DC resistance, we can simply ignore all of this and simplify it down to this. So we have just the the EL84's resistance 4404 kilo ohms. Now what I tried to do using the actual circuit which I had partially built out by now, and also the PSU designer software, was I tried to get as close to 250 volts as possible at this point, so that the voltages at this point would also be close to the correct at around 233 volts. So after some back and forth between the software and the actual circuit, I settled on these values. R16 is now 1800 ohms in parallel, to 1800 ohms in parallel, giving 900 ohms. R1 stays the same since L1's DC resistance is negligible. I had to change the transformer secondary voltage in the PSU designer to better match the actual output of the real rectifier, which was 300 volts DC with a dummy load. I guess that's expected as I have no idea what the transformer secondary voltage was actually specified as, because the Philips radio schematic does not mention that. Originally I measured 255 volts, but that was unloaded of course. Anyway, I have all this wired up, so let's go to the workbench and check it out IRL, as the cool kids would say. Okay, so the wiring is complete. The wiring of the power supply section has been completed. The amplifier is switched on right now through the isolated variac and the dim bulb tester. The dim bulb is glowing slightly. We have around 240 volts at the input, and at the node supplying B plus to the EL84 output stage, we have 244 volts. So very close to our predicted 245, and only around 6 volts off from the 250 volts as specified on the AX84 schematic. Now when it is plugged directly into the mains, the input voltage will be a little bit more than what we get out of the variac and the dim bulb tester. So this voltage will be slightly higher, but as of now it is close enough for all practical purposes. And after building the amplifier stages, I might play around with the resistor values a little bit more. Let's see. And right now this is loaded. This is the loaded voltage that we are getting with a dummy load of 4.4 kilo ohms. This is a 20 watt resistor, and this is pretty close to the 4404 ohms that is our calculated load resistance. But again, that is approximate, and all this is approximate, so we might have to play around with the resistance values as we go along.
So now I'm going to turn this off, unplug it from the variac, turn off the supply to the variac, and we'll take a closer look at the wiring.
Okay, so the partially completed amplifier has been switched off, the variac has been switched off, everything is unplugged, and I have let the filter caps discharge for a while. So it should be safe to poke around in this for the time being. Over here, we have the mains coming in through the grommet. The ground lead, the earth lead, is grounded to this washer, which is firmly bolted on to the chassis. Now this is not an ideal ground point because this washer and this bolt also hold down one of the bolts of the power transformer. So ideally this should be a separate point because the vibrations of the transformer can loosen this over time. So I will probably be changing this, either that or I might attempt to solder it onto the chassis. Let's see. So from the mains we also have the live and neutral leads. Now the live lead goes to the fuse holder where a 2 ampere slow blow fuse is inserted, and then we have the twisted pair cable to reduce hum going to the single pole double throw switch, the power switch, and the output from the switch, this lead, is going to the primary of the power transformer. Now I really should have put some heat shrink on there, but I don't want to redo that now because it was not easy soldering onto these chunky terminals. You need a lot of heat so that the solder flows properly. So I will have to think of a way to insulate this properly, but for the time being I'm going to let it be and be careful not to touch that when the amplifier is powered on. Over here we have the twisted cable, again to reduce hum, coming from the secondary and going to the full bridge rectifier module. This node is straight off the positive output of the rectifier, and this is the main reservoir filter cap. And here are, from that same node, here are the two 1.8K resistors in parallel giving 900 ohms going to the filter cap and forming the node which supplies 250 volts to the EL84 output stage. This I believe is a bleeder resistor, the 220K bleeder resistor, and this is R1, the 10K voltage dropping resistor for the preamp stages. Now R1 goes to this connection over here, which is going to the filter choke in the output transformer. This is the return from the filter choke in the output transformer going to this capacitor over here. Therefore this is the point which supplies 233 volts or close to 233 volts to the preamp stages. From the previous main B plus node which supplies the EL84 250 volts, we have another resistor going to another filter cap. This is a 1K resistor, and this forms the node that supplies the screen grade voltage for the EL84 output stage. All the capacitors, the negative side of all the capacitors are connected together and are connected to main chassis ground from this point. Now for the time being I am following the ground scheme shown in the chassis layout that I showed you earlier. However, I am not convinced that this is an ideal setup, so I might change it later. I will see about that.
So that's pretty much it for the power supply section. I still have to do the 6.3 volt filament, the filament wiring, for which I am waiting for the tube sockets to arrive. And this is not fixed for sure. I might make some improvements later on for safety reasons, such as improving, like I mentioned, this main chassis earth point, and also to reduce hum later on if there are issues, or even before I face any issues I might rethink how to do the ground scheme of this amplifier.
Okay, so that about wraps it up for this first part on my ultra low budget AX84 tube amp build. So stay tuned for part 2, and that means you have to subscribe to my channel and like and comment and all that stuff that you're supposed to tell your viewers to do. And also you should follow me on Instagram. I am much more active there than I am on YouTube, and my handle is @_electro88, and you can also follow me on Facebook electro88. So, yep, that's it. Have fun, stay safe. Remember that tube amps can kill you. Kind of a buzzkill to end it on that note. But yeah, do be careful. And I'm not an expert, so if you do notice any errors in anything that I've said, you notice me doing something wrong, please let me know in the comments below. All right, cheers. Have fun.